Hi, welcome to Cybernet Security. In today's video, we're talking about hashing function, and digest. So, what is the hash? Is the hash is simply when you pass your plaintext passwords or your pacify through a hashing function or hashing algorithm. So, mathematical computation will be done on them, and they'll give you an output which is known as a hash or a digest. So that is simply what an hash is. So why do we have hashes? We have different types of hashes though. Okay, we have different hashing algorithms. We have the MD5 hash, which is not always advisable. It's not safe now because of the high level of hash collisions that occur in MD5 hash. Some scientists have discovered that it's easier to to expose some certain passwords that are being stored using an MD5 hash. So MD5 hash, we have the SHA-1 hash. Um, the SHA-1 hash is probably a 160 bits hashing algorithm. So we have the SHA-2, we have SHA-3, we have SHA-256. So 256 is a bit more secure, more than the MD5 and SHA-1, SHA-2, and the rest of them. So we have other hashing algorithms, but for the purpose of this video, we explain what is hashing algorithm. We have use cases where hashes are being used. Hashes are used for integrity checking. For example, when you want to download a file from a web server, for example, sometimes when you want to download files, some web servers will provide you with the hash value of that file. And why they are providing you with that hash value is to confirm when you have downloaded those files, you hash it again. You hash the file to confirm if they have the same hash value, or if an attacker has manipulated or changed the file. With that, you could be able to tell that this file is actually what the original owner wanted it to have. So you only use hashing when information is being passed across the internet, for example. So when a client's machine, like your browser, is sending a message um, to to a web server, for example, the web communications. So they use hash values to confirm that there is nothing like man in the middle attack, so that the files that are being sent by the client is what the server is receiving, and what the response from the server is actually what the client is receiving. So it proves integrity. You equally use hashes to save passwords on databases. For example, you don't just save, you don't just save password just like that on your database, or you can actually encrypt your password, or you use hashes. Hashes are more faster, because using hashes are faster. So because when a user is creating an account with a web server, for example, you are creating an account with Facebook or something, or some kind of applications, so you do provide your username and password. So how are these information being stored in the database? The information that are being stored in the database, hashes are being used to store these informations in the database. Like, for example, your password in the database, so it will be saved in clear text, in plain text. Yeah. So when this information is being stored in the database, as some sort of hashing has been done in that password, it's being passed. That password is being passed through a hashing algorithm or a hash function, and after it has created a hash digest or a hash, the hash digest the hash is being stored in the password, not the plain password. So what are the major flaws to this hashing? For example, yeah, hashings can be, they are one-way conversion cryptographic functions. Like, for example, when you hash a value, for the server to confirm, when you are, for example, you created an account and you hashed a password, and so yes, this is a graphical representation of how these hash functions, the digits, are being stored inside your password in your application. So the database of the application. So when you enter the password, for example, you enter your strings and password strings, and these password strings are being passed through the cryptographic hash function. These cryptographic hash functions can be your MD5, can be your SHA-5, no, SHA-1, can be SHA-2, can be your SHA-256, can be your SHA-512. So depending on the hash function that you are using, or like the application is using, So it's a digest. It outputs this hash digest or a digest. This hash digest is a fixed size. The fixed size has a hexadecimal value. So this fixed size hexadecimal value what is being stored in the password database. You understand of that application. So it depends on the hash function you are using. That tells you the size of the size of the digest. Yes, these are different SHA algorithms that we have, but not the only hashing algorithms we have. Like I mentioned earlier, we have the MD5, we have SHA-256 and SHA-512, and many of them. So it's just an example. So we have a lot of hashing algorithms. So like I said earlier, hashing algorithms are meant to hide real information, that the real data that is being stored in database, to make it more secure. So what are the pros of this hashing? There's so many issues that come with hashing. So one of the issues that come with hashing is the issue of the hash collisions. So hash collisions are actually when two different files gives you the same type of hash, and it's just like when you have 10 objects to store in a 5 containers. So the tendency is that each container we have more than one object. So that is what happens in hashing. So when you have more data to hash and the hashing algorithm has a fixed size, you have more information to hash, which these hashes has unique they are unique hexadecimal strings, they are unique hexadecimal values. So their tendency is that some different data or different values can have the same hash or the same digest. So that issue has been seen to happen numerous times with SHA-1 and MD5 hash, which most applications that security is very, very paramount try to avoid this particular type of hashing. Or another thing you can do to improve this hashing safety is, for example, you can use sorting, and there's sorting, there's peppering, and there's multiple steps hashing. So sorting is when you get the maybe password value and you add a unique data to that. For example, you add unique strings to an already given passwords to differentiate that password. So what happens is, if a user is to store a password, the same password, these two identical passwords will have two different hashes. Why? Because sortings are unique to each user or to each entry. So, but one major issue that sorting has is the sorts are being stored in the database. So when a database is being compromised, there is tendency that if an attacker has an access to the sort values of those users, he can be able to tell what's the password or the original password of those hashes by performing some kind of attacks, dictionary attacks, and so on and so forth. So but another way you can equally improve the security of those hashes is by using peppering. So peppering is like it's like similar to sorting, but sorting, like I say, sorting is unique to different users, but peppering can be the same value. But one of the major benefits of peppering is peppering values are not stored in the database. So once a database is being compromised, there are tendencies that the peppering values, they still don't have the peppering values. So these peppering values are stored in the source codes or somewhere else that is more secure than storing them in the database. So, and these peppering values are not unique, just like I said earlier. So once you have added the salt and you have added the peppering, so it kind of gives variations to what the hash that you get when you are hashing the same values of you're hashing the same value, the same data values, or the same file. So another way you can improve hashing is when you perform multiple hashing on a hash. For example, after you have gotten a hash of a value, you hash that hash depending on the number of steps you want to hash that hash. Understand? In that way, it can actually secure the original hash of that value. So that is for hashing. So like I said earlier, hashing, a type of cryptography, is one type of cryptography. We have other forms of cryptography. Don't forget to like and subscribe my YouTube channel, do cybersecurity courses. And so currently we are having a training, a class, an institute, Cybernet Security Institute, where we train professional cybersecurity engineers, or we train people who want to move into the cybersecurity space. It doesn't necessarily need you to be an expert. You can be a beginner. So we train professionals from zero to hero. So we have the next batch of our training to start in April 1st. It's an online program. It's an online program that is meant to last for 12 weeks. So we kind of guide you in every step to make sure that you have the required resources, you have the required knowledge to fit in into any cybersecurity role. So that is it. So thank you. Do have a lovely day. Don't forget to like and subscribe.